welcome to another set of video notes. Today we're going to go on to 2.7. We're going to look at absolute value functions and transformations. Now, remember, functions is just a fancy way of saying that each input can only be mapped to one output. So one domain can't have a choice, okay? What we need to look at is for absolute value, what does the graph look like? Well, if we put 0 in for x, we'd get 0, right? If we put 1 in for x, we'd get a positive 1. Can you think of any other ones? Oh yeah, if you put negative 1 in for x, what's the absolute value of negative 1? It's also 1. 2 is 2, but so is negative 2. Hopefully, even though my graph isn't the greatest, you're getting the idea that it's going to be a symmetric V. So all absolute value equations, whatever they are, whatever you do to them, are still a symmetric V. So linear was always a line, absolute value, it's always symmetric V. Now, there's a couple things I want you to notice about that, and I've given you this big formula. And if you can figure this out now, and I think it's chapter 4, when we get to something, you're going to go, oh, wow, this is easy, okay? If we subtract something from x, we're going to refer to that as h. And anything that we put outside of the absolute value, we're going to call k. And anything like this, here's your new vertex, okay? So the h is going to be how far you shift the vertex. Let's see, it's an x-coordinate, so it's going to be left to right. Shift left or right. And then k, look here, k is a y-coordinate, so the y-coordinate tells us up and down. So this is going to be a shift up or down. Now these are probably the things you'll want to get down, not only in your notes, but also on your study card, because it will help you remember, okay? Also, I want to point out to you that since the formula has a negative in it, whatever you see there, take the opposite of what's there for h. Okay? All right. So what I'm going to do is we're going to look at a couple examples. Now, I know I normally have the example written up for you, and you write it down, and then you put the solution in your notes. Today, instead of me writing them, they're going to be up on this screen. Okay? So, look at this. We're going to graph x plus 4 minus 2. Compare the graph with the graph y equals absolute value of x. Well, you notice we've got some values for h and k. You might want to pause the video right now and get this example written down. Okay, you back? Good. Then we're going to talk about this. So, the h, we're supposed to take the opposite of what's there. So what's the opposite of positive 4? It's going to be negative 4. And then k, and maybe we should write, and then take whatever is there. Let's see if I can write this way. Whatever is there for k. So, what's there? A negative 2. So I'm guessing the new vertex is going to be a negative 4, negative 2. Let's see. Step 1. Identify and plot the vertex. Hey, we did. It's negative 4, negative 2. So now, when you go to graph it, instead of starting it at 0, 0, we're going to go over to negative 4 and negative 2. Okay? So let's see that. Or, well, I guess we won't see it yet. But then pick another point, such as negative 2, 0. Now I'm going to show you this. Let me show you. So, instead of being right here like we normally would, we went over 4 and down 2. And then maybe we put in the point like negative 2. Well, let's see. Negative 2 plus 4 is 2. Absolute value of 2 is just 2. 2 minus 2. Oh yeah, that's 0. So then that third comment, using symmetry, think about this as being the folding line. If there's a point here, where else should there be a point? Oh yes, over here. So 2 away, 2 away. If you look at, here's another one, come up, it's 1, 2, 3, 4 away. Oh yeah, 1, 2, 3, 4 away. And so that gives you the V then, okay? So we need to, step 1, and maybe we should write these over on this other board, okay? So to graph absolute value stuff, okay? First thing you're going to do is find the vertex, okay? We're going to leave some room because I'll probably change numbers in a minute. So we found the vertex, and then you're going to think I can't count, but we're going to look at some other things. And then we're going to pick a number for x, plug it into the function, or to the equation, to find y, and then I'm going to tell you, plot that point, xy, okay? Then use symmetry, or we might call it the folding line, and I bet my writing is getting kind of light. Folding line to find another point, okay? All right, so we look at what we did. We found our vertex. We put a number in for x. It was -2. We plugged it in, found out that its y was 0. We graphed it, and then we said, okay, well, like, think of it being folded. There's a point here, there's got to be a point here. We connected it, okay? Now, here's the thing. You can compare it to the original. Well, it was shifted to the left 4 and down 2, okay? So H shifts left or right. If it's a negative, it's going to shift left. If it's a positive, it's going to shift right. This one shifts up if it's positive and down if it's negative. Let's go back and look. It was a -4, so shift left like we said, and a -2, so shift down. Okay? Let's try, well, we talked about that. Okay, let's look at this. Now notice, do I have like the H and K stuff? I don't think so. We have a number in front, so we're going to come back to our board, and we're going to look at what this A number refers to. Now, A is less than 0. So what kind of numbers are less than 0? Oh yeah, if it's negative, then the V becomes upside down. It gets flipped, okay? The other thing we need to watch is if it's a fraction, like 1/2 or 1/3, something between 0 and 1, then the graph itself gets wider, okay? If it's a big number, then it's going to get skinnier. So let's look at some of these, or the V, maybe we should say. So let's look at some of these examples right here. Our first one says, let's graph y equals 1/2 absolute value of x. So the 1/2 is definitely out front. And you might think to yourself, is it negative? No, but it is that 1/2. So let's see what happens. Do you see how it gets fatter? Okay, your book gets really into having you graph exactly. I'm not going to get into that. I'm going to just ask you to describe what happens to the V. In this case, it got wider, or it got fatter. Okay? Now, let's look at another one. Now, this says -3. So is that a number less than 0? Definitely. So it should flip upside down instead of being like a V. Be like that. And what happens if that's kind of a whole number? It's going to get skinnier. Okay, so let's look at it. And you notice, here is our normal one.
Mr. Prowell, you have a phone call parked on 1. Mr. Prowell, press *11 for a phone call.
It's like you're in class because we still get interrupted. sorry about that. So this is flipped, and notice it's skinnier, right? Okay, so that's really what I want you to take away from this. Okay, now, we're going to come back over here, because you might say, Mrs. Ruff, you can't count. You've got 1, you've got 3, and you've got 4. Because number 2, we have to look at A, okay?
Spencer Harvey, your right is here. Spencer, please come to the front hallway. Spencer Harvey.
Use the rules. Okay, we'll just leave it like that, and we'll talk about some more. I have a whole bunch more examples for you, so let's come over and look at them. Okay, wow, we've got a lot going on. We've got an A, we've got an H, and we've got a K. The first thing we need to do is figure out the vertex. Now, this is already negative, so do we keep it negative or make it positive? Oh yeah, H is the one you take the opposite, because there's a minus in the formula. So what's the opposite of -1? It's +1, and we use what's right there. So 1, 3, and I think the book does it, oh, not exactly in the same order. So 1, 3. Now look, it flipped it. Why did it flip it? Oh yeah, because this is negative, and it definitely got a little bit skinnier because that's a big number. Okay? So that's what I'm really going to ask you to do. I'm going to ask you, what's the new vertex? What is the A? What should happen to the graph? If we look at this one, we can say, well, the vertex went 1 to the right, because 1 is positive. It went 3 up, because 3 is positive, and then flipped it because of the negative, and it got skinnier. Okay? I think I probably have a little more to practice with you. Oh, and here they go through it. Okay? Now, they actually graphed it, so they just put in a point like 0. 0 is easy. Put 0 in, 0 minus 1 is -1. What's the absolute value of -1? Oh yes, it's 1. 1 times -2 is -2. -2 plus 3 is 1. And then they use symmetry to get the other point, just like we did before. Okay, let's look at another example. Here's some extra practice. We've got -2, 5. I'm wondering, can you find the vertex right away? Well, you need H. Do you take H or the opposite? Oh yeah, it's opposite, so that's 2. Your K is going to be 5. So now let's think about this. It's going to go 2 to the right and 5 up. Will we flip it upside down? Will we change how wide or skinny it is? Nope. So let's look at that. 2 units up, 5 units, and that's all we've done different. Okay? Look at this one. This is 1/4 x. Now, it's still going to be at 0, 0, right? Because there's no H or K. Does this number make it go upside down? Oh, I hope you all said no. It would have to be negative to go upside down. What does 1/4 do? Oh yeah, it makes it fatter. So let's look at, it'll give us a graph. Yep, it made it a lot fatter, but it's still at 0, 0. Do you see what we're going to be doing? Okay. Let's look at this last one. This is really busy. It's got all kinds of things. We've got A's and H's and K's. Oh my. We've got lions, tigers, and bears thing. So what's our H? I hope you said -1. What's our K? -2. And our A is -3. So we've got -1. Now notice each one of these lines is worth -2. So that's why they have -1, -2. They flipped it upside down and they made it a little skinnier. Okay? That's what we're going to be doing in our homework. So I'll see you soon and we'll practice. Bye.